Hi, thank you for coming. Thank you for having me. I'm here to talk to you about AI versus rule-based static code analysis. I am and who am I? Why do I have standing to talk to you about this? Look, here's a picture of me. It's the same picture of me that's on everything. I love this picture of me. It looks like I'm Ernest Shackleton. I'm actually on the boat from Neon to Ivoire, going across Lake Geneva in the winter. I'm Kendrick. I'm Director of Technology at Codacy. What Codacy does, software development, 4-year masters in computer science systems and software engineering, 18 years in software, mostly PHP and JavaScript. Sorry, I did do some C# once in 2011. I hope this is still relevant. I'm a Scrum Master, I'm a game designer, and what I call a thought follower. I don't write posts on LinkedIn with new thoughts, I just consume everybody else's. So that's me. So it's Friday night. We could be here talking about AI, or we could be having a beer. Right, I've actually got a Coke right here. So let's just take a quick check to make sure we're spending our time on some of the features of beer versus AI before we start. So beer is fun. It is easy to overconsume, can get expensive, and it'll lead you to making bad decisions and talking nonsense. On the other hand, AI, yeah, okay, let's do the talk. Right, so this little bit's going to be salesy. It's not really. You'll see the point in a minute. But what Codacy does is we run static code analysis tools for you on your code, on your repos, and give you the results. And we let you gate your PRs based on them, which is pretty cool. But fundamentally, we support 40 programming languages, of which C# is one, and more than 50 tools. And there are 10,000 configurable rules in our universe for static code analysis, which is pretty cool. But that's a lot of work to maintain, right? Keeping all of those tools and rules up to date, piece of work for us. So what if we didn't have to do that? What if AI could just replace all of those tools for us? Wouldn't that be great? Because then we would have a much easier job, or we'd be out of business. Not sure which. Well, let's dive in and have a look. So I'm going to stop sharing the presentation for a sec, and instead we can switch to some VS Code. I hope everybody can still see. I've pulled up an old version of one of Codacy's own files, which is in Scala. Sorry. In VS Code with a little plugin that I've been messing around with called Codacy, which does all sorts of stuff. But one of the things that it does is allows you to run static analysis through OpenAI using ChatGPT 3.5 Turbo. If that means anything to you, it will create a prompt. It will fire chunks of your code off and ask it to pretend to be a static code analysis tool. And what happens if we do that? So I pressed the button earlier to save us a little bit, that it is a bit slow, and I will push the button again at the end to show you that that's the case. So one limitation as AI stands right now is that it's not that quick in solving this problem. But yeah, let's just dive in and have a look at a few of the things that it's picked out. It's finding a name constant. Something that you will see over and over again is terrible at actually finding the right line number of your issue. So we're looking at number 15, which presumably is talking about this here, but it's actually only managed to figure out how to put the line number for the issue it's found all the way up here. So not super accurate. And we've got some hard-coded credentials. We've got some unvalidated input, which it picks up quite a few of. It loves talking about unencrypted cookies, if you can find them. So it'll say, and this is a file about Cookie Helper, about doing cookies, right? So it will give you a few interesting things. I like this one particularly. This is a genuine cookie-only flag making vulnerable cross-site scripting attack. Great, it's found an error somewhere. We can just go and find that there is a reference to HTTP only in a few places in this one, HTTP only being set to false. So that's pretty cool. It's finding stuff. It's not getting it quite in the right place, but you know, that's still interesting. It's getting there. What I'm going to do for you now is I'm going to push this button again. So like I say, when I push this button, what's happening is that we're starting again. We're taking the whole file from scratch. We're taking in 60-line chunks, pumping them off to OpenAI and getting the response, which has its obvious limitations already, right? Very often it might pick it up this time. It will complain that you've got unused import statements because it finds something like Scala util try that's not used in the first 60 lines of this file, right? And so it will say, as far as it's concerned, in the context that it's got, that there's an error here, and there's not. Obviously, as AI gets more advanced and we can either pump more context in or set more models up, the windows and get bigger, but for right now, that is a pain point. And I've done a lot of talking so far, and it's still not returned any results. I do wonder if I actually clicked the button correctly. It must have done, because it wiped that out. Yeah, here we go. We're starting to get some now. And indeed, it has picked up somewhere. It hasn't, it's just underlined that one. So having pushed the button again, here's another interesting thing about using AI for doing static code analysis. It's given different results. And some of those might be valid as well. There's still a fair amount of noise here. But if you are relying on your static code analysis for doing compliance or for definitely detecting a specific set of issues, then again, AI in inverted commas is really not quite there yet, right? So that's what we've got there. By comparison, I just flip over to the repository view from Codacy. It's done some weird autocomplete there. And wait a few seconds again. What this is going to do is this is going to pull down all of the issues within this file from a previous static code analysis run using Scala Meta Pro and whatever else is configured in Codacy for this file. And there are indeed issues within this file, but they're not the ones that the AI has picked out. So it's very big on somehow the AI is executed on top of that. Sorry, let me just run that again just for the repository view. There's one specific error that it finds lots and lots of times about prohibiting insecure cookies, but not anything else. So the AI found different useful things compared to what we found, but it wasn't consistent. And it found a lot of noise as well. And something that people hate about static code analysis is when you generate a lot of noise. You can go and do the same sort of activity on other file types. So we can go and look at here's a markdown file. If we want to do the same thing, it's actually interesting that the AI either gets markdown really right, and it will correct your spelling and tabbing and formatting errors within Markdown. I mean, you can see it white space between two hashes and the text and not there. Or it will think that you're trying to execute a code file, and it will complain about things that look like HTML or that look like code, and completely get it wrong, which again, in terms of bad decisions, not great. You can ameliorate a load of this stuff, of course. Talking about the import statements, you could, before you pumped stuff into your AI, you could say, okay, well, we know that import statements is a problem, so we're going to put a special condition in, and we're just going to skip over the import statements, right? And then we'll just ask it to not do those, or maybe we can just search for references manually for all of those so that we don't need to do that. And again, you can, but you've just generated a new piece of work that you then have to maintain forever. And you certainly can't do that easily across 40 different languages. So that's a problem. We're not getting any response from the AI at this point. Oh, there you go. It's found lots. That's fun. Another weakness I found with AI, we can have a look at the errors in a sec, is that in Codacy, we support 10,000 rules. You can turn them on and off. You are getting noise in your linter because either because you work in a particular way or because you have a legacy code base that's got lots of the same kind of problems in. You know, something we find a lot in category I'll flip back over to the repo view in a minute, but you'll see that there's always a ton of code style errors in pretty much any repository that's analyzed within Codacy using rules tools, which a lot of people don't really care about, or they're going to use Scala Funct or whatever to wipe them out anyway, and they're not interested in fixing those. Whereas AI is going to pick those things up every single time, unless you start writing a very long and complicated prompt to say, and don't consider this, and don't consider that, and don't consider that, in which case you're going to have the that problem where you're filling up your prompt with instructions, and then you don't have enough of a window to pump in enough code to get some good results. So yeah, let's just have a tiny look at what it's telling us about Markdown. So somehow it's decided that this is unused code. The public API v3 section is no longer relevant. I can tell you the public API v3 is pretty relevant in Codacy, but it's picked up some unnecessary white space. Unfortunately, because it can't get the line number right, we don't know where the unnecessary white space is. Never mind. So today it seems like it's decided that this is code and is trying to treat it like code. Rather than necessarily thinking that it's Markdown. Oh well, never mind. So let's flip back to my presentation. I tried to come up with a name for this. Codacy IDE? Don't know. Yeah, so what do we do then? We get inconsistent results, incorrect results. We can't necessarily pump enough context in for it to make sense. We don't necessarily get enough output. So something you didn't see is that the code behind the prompt to OpenAI asks it to limit itself to only the top 10 issues that it finds in any particular 60-line chunk. But actually, there could be more than 10 issues, right? But you don't know how many you're going to get, so you can't optimize the prompt size to send you back absolutely everything. And so there's potential, again, as it's set up now, that you might actually miss issues. You could do something cleverer, again, by breaking it into functions and trying to pump the entire function context in for each call. Again, as someone who's involved in code quality, I know there's a lot of code where you're going to have functions that are more than 60 lines. And so if you've got a 100, 200 line function, I mean, that's a code smell by itself, but at the same time, your AI static code analysis is going to struggle. It is still kind of fun, though. It is kind of fun to play with these toys. But there is maybe a different way that AI can help us, because, you know, AI is always very insouciantly confident about what it's doing. You know, it will always give you results, whether the results there to give or not. It will always try to tell you something. But that means we can do something different. So we've been messing around with this with Codacy ourselves in the principle of automatic fixing. Here's a little screen grab, and I'll go and find some in a sec. I've closed my browser, so I'll go and poke around in my history, unfortunately. But we can take rule-based static code analysis failures, and then we can actually get AI to do its very confident and not necessarily always correct job of describing what the error is to the developer with a bit of context, because we don't just shoot it the line with the issue in. We'll put a few lines either side. We can get a nice description out and even suggest what you might change it to. Now, even this suggestion here has a mistake in it, right? So great, it's changing the double equals into dot equals method, which is great, but it's also removing all the white space off the beginning of the line, and that's something that we're working on fixing right now. But you can see that it's doing something pretty useful there. This is taken from GitHub's suggested fixes mechanism, which in open PRs, then you can just press a button to say, like, commit that suggestion, which is pretty cool from GitHub. Yeah, so we're not going to try and do static code analysis with AI. because we kind of proved that it doesn't actually work that well. And it's expensive as well. I haven't mentioned that so far, but each time I pressed that button, there was actually like whole numbers of cents flying out of our bank account for that sort of crummy static analysis on one file. If you extend it across an entire repository, you can be spending $50 for a pretty miserable output. And sure, it will get better. But fundamentally, I think the commenter said that everyone's trying to use an AI-shaped hammer on a nail is bang on. Can I say bang on? Because actually, if you look at what the problem you're trying to solve is, really you're running a bunch of regular expressions which have pretty well-defined constraints on them, and that's giving you output. What you're trying to do is use a fantastically complicated, like Markov chain, Bayesian probability, large language model with billions of lines of similar code put in there to try and infer how a regex should work. So, like, for me, the regex is always going to be cheaper and faster. You saw how long it took to actually produce some output for that markdown file. Well, actually, if you run markdown lint on that file, you can run markdown lint on the entire repository in like a few milliseconds. So AI is definitely not winning on speed or cost at the moment. And again, maybe it'll get better. Maybe there's a future where just everything is AI because it's so cheap, the cost is irrelevant anyway. But yeah. So I've got a few examples of. In fact, we've got some C# ones. So let's maybe look at those since they're relevant. So this is one of our sample repos where we've tried to put in some issues and then ask the AI to describe what the fix should be, right? So here's a medium error prone issue. I haven't looked at the C# one before. I've looked at the C++ ones and the TypeScript one. This is asking it to put in a static to define this class. I'm not sure why it thinks that. Does not have a constructor, is not marked as static. So presumably, if it doesn't have a constructor, it should be marked as static. So there you go. We'll try and stick that in. And the same again. And that's not a great example on this plus one. There's a few where it's actually trying to text view looping around inside the loop, don't define it afterwards. Yeah, here we are, this one. Which, I mean, this is listed as a minor code style issue, but actually reducing, I think this is actually fairly serious because you could wind up using J in a separate for loop further down the same function, not realizing that it has wound up getting to some value before you start moving inside the loop. Means that you've set this so you can do things like that. So I thought that was a nice one. Again, we're still not doing the indentation properly, but I think that is the most easily fixable part of this problem here, right? Some initialization. It's assigned a value that's never used, so let's not initialize it because you don't want to do that. There was another nice one about not messing around with, this might be the TypeScript one, don't change the, here's a nice, like, on the one hand, this is great. This is like, it contains a magic number, and we explain what magic numbers are. Magic numbers make the code less readable and less maintainable. It's unclear what the number represents. To fix the issue, assign it to a constant with a descriptor name. Great. All great stuff, except, of course, the AI is not clever enough to tell you what that 5 actually represents, right? And I think probably because this is in FizzBuzz, that's perhaps an unfair challenge to ask of the AI, right? Because probably the fact that it's 5 is entirely arbitrary, and so assigning the constant to be 5 is possibly AI having a laugh at us. Maybe if it had context of what the problem was with better variable names, it would actually suggest a better constant name, but possibly it wouldn't. I don't know. But even so, like, solve magic numbers, perfectly valid use case. There's one in here which is to do with changing the value that's in the argument. Again, it's really nice. It's like, don't if you've got an input that includes n, then don't actually reassign the argument, assign it to a new variable. I thought it was in here somewhere. And it gives you a very nice autocorrect for it. And for any of these things, again, this is GitHub's feature, not ours. Then you can just ask GitHub to just commit that suggestion right now, stick a description, and press the button. I'm not going to press the button because that's going to mess around with someone's dev work at work. But that means that you've now got a way where any of the suggestions that your AI does come up with that you do like the look of, you're actually only 2 clicks away from actually implementing it. And in terms of making developer like microcycles faster than just going, yeah, that's good, yeah, that's good, yeah, that's good. No, I'll ignore that one. No, I'll ignore that one. Then that's pretty cool. So yeah, that was the other bit of the stuff I wanted to show you.